sequence is a succession of terms that are related to one another according to a well-defined rule or pattern. Now, under sequence, we have arithmetic progression and geometric progression, that is AP and GP. But first and foremost, we will start from arithmetic progression before we get to geometric progression. We'll take a look at arithmetic progression. We'll consider the nth term of an arithmetic progression and the sum of n terms in arithmetic progression, after which we'll take examples under arithmetic progression before we go over to geometric progression. So, arithmetic progression. AP. Now, an arithmetic progression is a sequence in which there is a constant increase or decrease in value between its consecutive terms. I repeat, arithmetic progression is a sequence in which there is a constant increase or decrease in value between its consecutive terms, and the differences between its consecutive terms is known as common difference. Now, let's take for instance we have 2, 4, 6, 8, 10, and maybe 12. Now, if you watch closely, there is a constant increase in value from 2 to 4, from 4 to 6, from 6 to 8, from 8 to 10, and from 10 to 12. And if you watch, the differences between any consecutive terms here is 2. For instance, from 2 to 4 is an increment in 2. From 4 to 6, there is an increment of 2. From 6 to 8, there is an increment of 2. From 8 to 10, there is an increment of 2. And from 10 to 12, there is also an increment of 2. So, this is an arithmetic progression, and in this case, the common difference, D, between the consecutive terms of the AP, the common difference, D, is equal to 2. As I have explained earlier, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, and all that. So that brings us to what we call nth term of an arithmetic progression. Nth term of an arithmetic progression. Let me abbreviate it. Of an AP, arithmetic progression, AP. The nth term of an AP, Tn, is given as A plus m minus 1 all multiplied by D, where Tn is the nth term, A is the first term in the sequence, n is the number of terms in the sequence, and D is the common difference in the sequence. From here, we'll go on to the sum of terms in an AP. Sum of terms in sum of terms in an AP. Now, in a game, we say that AP is a kind of sequence in which there is a constant increase or decrease in value between its consecutive terms. For instance, in this sequence that we have here, there might be an omission such as this, and you are asked to find the sum of so terms, say maybe from the first term to the fourth term, or from the fourth term to the ninth term, to find the sum of the terms in that AP. Now, to do that, there are formulas that you could use to do that, and the formula is this: xn is equal to n divided by 2 into 2a plus m minus 1 multiplied by d. This is the formula we use in calculating the sum of terms in an arithmetic progression. But on the other hand, if you know the first term and the last term in the sequence, there is another formula that you could use that is shorter and simpler, and that other formula is xn is equal to n divided by 2 into a plus l. When n is the number of terms in the sequence, a is the first term, which you must know, and L is the last term, which you must know before you can use this other formula. Otherwise, if you do not know the first term and the last term, or maybe you know the first term and you don't know the last term, then you can use this other formula. But if you know both the first term and the last term, then this second formula is simpler and more straightforward in calculating the sum of terms in an arithmetic progression. And from here, we'll just take few examples. With the few examples that we are going to take, I will show you how you can use the formula we have listed on the board before now in solving problems that involves arithmetic progression. Take a look at the example we have on the board. Find the fourth term of an AP whose first term is 2 and the common difference is 0.5, and B, find the sum of the first 4 terms of the AP in question 1a above. Solution. Now, find the fourth term of an AP whose first term is 2. We have that the first term A is equal to 2, and the common difference D, is equal to 0.5. Now the question says find the fourth term. We say that the nth term of an AP is given by this formula: A plus m minus 1 all multiplied by d, where Tn is the nth term. So here we have T4 because we are looking for the fourth term. T4 is equal to A. Our A, which is the first term, is 2, plus our n here is 4 minus 1 multiplied by d, which is our common difference, 0.5. This is equal to 2 plus 4 minus 1 is 3 multiplied by 0.5, and we have 2 plus 3 multiplied by 0.5, we'll get 1.5, and this gives us 2 plus 1.5 as 3.5, and that is the value of the fourth term in the arithmetic progression that we have on the board. That is the fourth term, 3.5. Then the second question, 1b, says find the sum of the first 4 terms of the AP in question 1a above. The sum of the first 4 terms. Now, we know the first term, we know the common difference, and we know the fourth term to be 3.5, but we do not know the last term. So the formula we are going to use to find the sum is Sn is equal to n divided by 2 into 2a plus m minus 1 multiplied by d. The sum of the first four terms, so S4 is equal to n divided by 2. Our n here is 4 divided by 2 into 2a. Our a is 2, so we'll have 2 times 2 plus our n is 4, so we'll have 4 minus 1 multiplied by d. Our d, which is a common difference, is 0.5. So what we'll have here is 4 divided by 2, we have 2 into 2 times 2, we'll have 4 here, plus 3, 4 minus 1 will have 3. 3 times 0.5 will have 1.5. So that 4 plus 1.5 is 5.5. So we'll have 2 times 5.5, and that will give us 11. 2 times 5.5 is 11, and that is the answer to that question 1b that say we should find the sum of the first four terms in the AP. Alright, let's take a look at the second example we have on the board here. The fourth term of an AP is 37, and the sixth term is 12 more than the fourth term. Find A, the first term, and B, the seventh term. Solution. Now the question says that the fourth term, remember the formula of n term of an AP, which is Tn equal to A plus n minus 1 multiplied by d. So the fourth term, T4, they say is 37, is equal to A plus, n here is 4, so 4 minus 1, we have 3d. And the 3 is equal to 37. Now, the second one and the sixth term is 12 more than the fourth term. If the fourth term is 37 and the sixth term is 12 more than the fourth term, it means that the sixth term is 12 plus 37, which will give us 49. So we'll have that this one implies that A plus 3D is equal to 37. Call it equation 1. Then we'll have T4, T6, rather the sixth term is equal to A plus n in this case is 6. 6 minus 1 is 5, so we'll have plus 5D is equal to 12 more than the fourth term, that is 12 plus 37, which is 49. This implies that A plus 5D is equal to 49. Call it equation 2. Now we will subtract equation 1 from equation 2. If we do that, a minus a will give us 0, okay, and 5d minus 3d will give us 2d. This is equal to 49 minus 37. It will give us 12. Therefore, our d is equal to 12 divided by 2, which is equal to 6. And having found the value of d to be equal to 6, we substitute in equation 1 so that we can find the value of a. So, from equation 1 here, a plus 3d is equal to 37. A plus 3 into 6, which is our d, is equal to 37. A plus 3 times 6 is 18. A plus 18 is equal to 37. Therefore, a is equal to 37 minus 18, which will give us 19. That is the value of our a, and that is the first term. The first term is a, that is 19. Having found a, which is the first term, to be equal to 19, and d, the common difference, to be equal to 6, we proceed to find the seventh term. And you remember that Tn, that's the nth term of a GP, is equal to a plus n minus 1, all multiplied by d. So the seventh term, T7, is equal to a, in this case our a is 19 there, plus our n is 7 minus 1, multiplied by d, which is 6. Now we have that T7 is equal to 19 plus 6 multiplied by 6. This will give us 19 plus 36. And then we'll have it to be 19 plus 36 will give us 55. 55. That is the seventh term of the AP that we'll have on the board as example 2. I have the third example here on the board, still under arithmetic progression AP. 8 poles are to be used for pillars, and the lengths of the poles form an arithmetic progression AP. If the second pole is 2 meters and the sixth pole is 5 meters, find A, or give the length of the poles. B, find the sum of the lengths of the poles of the 8 poles. Solution. We're starting with A. we say we should give the length of the poles. Now, they say that the second pole is equal to 2 meters, and sixth pole is equal to 5 meters. From the formula we use in finding the nth term of an APT, n equal to A plus m minus 1 multiplied by d, where A is the first term, n is the number of terms in the sequence, and d is a common difference. Now, the second pole, T2, is equal to A plus n. N here is 2, so 2 minus 1 is 1. 1 times d will have d, so plus d is equal to 2 meters. This implies that A plus d is equal to 2. Call it equation 1. Then we'll go back here. T6 is equal to A plus, in this case our n is 6, so 6 minus 1 will have 5. 5 multiplied by d will have 5d, so we'll have T6 is equal to A plus 5d and is equal to 5 meters. This implies that A plus 5d is equal to 5. Call it equation 2. Now from here, we will subtract equation 1 from equation 2. A minus A is 0. 5d minus d will give us 4d. This will be equal to 5 minus 2, that is 3. Therefore, our d, which is a common difference, will be equal to 3 divided 4. And having found the value of d, we will substitute it in equation 1 so that we'll get the value of A. So, this is equation 1 here. A plus d is equal to 2. A plus, our d is 3 over 4. So we'll have A plus 3 over 4 is equal to 2. If we remove this bracket and do cross multiplication here, we'll have that 4a plus 3 all over 4 is equal to 2. What we simply did here is I will find the LCM of 1 and 4, which is 4, and we use it to multiply out. So if we cross multiply here, we'll have 4a plus 3 is equal to 8. 4 times 2 is 8. So from here we'll have that 4a is equal to 8 minus 3. And that means that 4a is equal to 8 minus 3 is 5. Therefore our a is equal to 5 all over 4. All over 4, which is the first pole. We then go ahead to find the other ones. Tn is equal to A plus n minus 1 bracket d. So the second pole T2 will be equal to A plus n. In this case, n is 2, so 2 minus 1 is 1 times d, so we'll have the T2 as A plus d. which is equal to, our A will find to be equal to 5 all over 4 plus our D, which will find to be 3 all over 4. And this will be, the LCM here is 4. 4 divided by 4 will have 4. 4 times 5 will have 5 plus 4 divided by 4 will have 1. 1 times 3 will have 3. This is equal to 5 plus 3 is 8 divided by 4, which is equal to 2. That is due to the second pole. Then, still from this formula, T3 will be equal to A plus, and here is 3 in the case of T3. So 3 minus 1 is 2 times D. So we have plus 2D, which will be equal to, our A is 5 all over 4 plus 2 into our D is 3 all over 4. And then we'll have this to be 5 all over 4 plus 2 multiply 3 all over 4 is 6 all over 4. The LCM here is 4. So 4 divided by 4 will have 1 times 5. There will have 5 plus 4 divided by 4 will have 1 times 6, which is 6. So we'll have that this is equal to 5 plus 6 is 11, all divided by 4. That is the value of T3, which is the third pole. Tn is equal to A plus n minus 1, all multiplied by D. Therefore, T4 is equal to A plus, and here is equal to 4. So 4 minus 1 is 3. 3 multiplied by D is 3D. That is the value of T4. This is equal to, our A will have as 5 all over 4 plus 3 into our D is 3 all over 4. This will give us 5 divided by 4 plus 3 times 3 will give us 9 divided by 4 here. So we'll have this to be equal to, the LCM here is 4. 4 divided by 4 is 1 times 5 will have 5 plus 4 divided by 4 is 1 times 9 will have 9. This will give us 5 plus 9 is 14 divided by 4, which will be equal to 7 divided by 2. That is T4, which is the fourth pole. Now we'll continue to the fifth one, T5. T5 from this formula will be equal to A plus m minus 1, that is 5 minus 1, which is 4 times D, will have 4D. T5 is equal to A plus 4D. And we'll have our A to be 5 all over 4. So we'll have 5 all over 4 plus 4 into our D that will have as 3 all over 4. Okay, and this will give us 5 all over 4 plus 4 times 3 will have 12 all over 4. LCM of 4 and 4 is 4. 4 divided by 4 will have 1. 1 times 5 will have 5 plus 4 divided by 4 will have 1. 1 times 12 here will have 12. This will give us 5 plus 12 is 17 divided by 4. That is the value of T5, which is the fifth pole. And then we'll continue to the sixth one, T6. Still from this formula, Tn equal to A plus M minus 1 multiplied by D. So T6 will be equal to A plus 6 minus 1, which is 5, multiplied by D, 5D. And our A is 5 all over 4 plus 5 into our D is 3 all over 4. So we have 5 all over 4 plus 5 times 3 will have 15 divided by 4. The LCM is 4. 4 divided by 4 will have 1 times 5. We'll have 5 there plus 4 divided by 4 will have 1 times 15. We'll have 15 there. So 5 plus 15 will have 20 divided by 4. And this will give our T6 to be equal to 5. 20 divided by 4 is 5. And that is our T6, which is supposed to be the sixth pole. We'll go on to get that of the value of the seventh pole and the eighth pole. E7, which is the seventh pole, is equal to A plus, still from this formula that we have here, Tn equal to A plus M minus 1 multiplied by D. So we have T7 to be equal to A plus 7 minus 1 is 6. 6 times D is 6D. And our A is 5 all over 4 plus 6 into our D, which is 3 all over 4. So we have this to be equal to 5 all over 4 plus 6 times 3 is 18. 6 times 3 is 18. We'll divide by 4. The LCM here is 4. 4 divided by 4 is 1. 1 times 5 there is 5 plus 4 divided by 4 is 1 plus 18. 4 divided by 4 is 1 times 18. We have 18 there. So 5 plus 18 is 23 divided by 4. That is our T7, which is the seventh pole. Then the final one, T8, is equal to A plus 7D. Still using the formula Tn equal to A plus M minus 1 multiplied by D, where N is 8. 8 minus 1 is 7. So 7 times D. That's all we have there. Our A is 5 all over 4 plus 7 into our D, which is 3 all over 4. And this will have to be 5 divided by 4 plus 7 times 3 is 21 divided by 4 here. The LCM of 4 and 4 is 4. 4 divided by 4 will have 1. 1 times 5 there will have 5 plus 4 divided by 4 will have 1. 1 times 21 will have 21 there. Then 5 plus 21 will have as 26 divided by 4. This is equal to 8 whole number. Sorry, 2 divide 2 here will have 2. 2 divide here will have 13 all over 2, which is 6 whole number 1 all over 2. That's the value of our T8, which is the find the value of the first, second, third, fourth, fifth, 6th, 7th, and the 8th term in the sequence. Here are the lengths of the poles in order from the lowest to the highest. 1 whole number 1/4 meters is the length of the first pole. 2 meters is the length of the second pole. 2 whole number 3/4 meters is the length of the third pole. 3 whole number 1/2 meters is the length of the fourth pole. 4 whole number 1/4 meters is the length of the fifth pole. 5 meters is the length of the sixth pole. 5 whole number 3/4 meters is the length of the seventh pole, and 6.5 meters is the length of the eighth pole. Now the second part of the question B says that we should find the sum of the sequence, that is sum of the 8 terms in the sequence. Part of the question says find the sum of the lengths of the poles Now we'll use this formula to do that. Xn is equal to n divided by 2 into A plus L, when A is the first term in the sequence and L is the last term in the sequence, and n is the number of terms in the sequence. So Sn here will be S8 because there are 8 terms in the sequence. This is equal to 8 all over 2 into A, which is the first term, is 1 whole number 1 all over 4, plus the last term there will have a 6 whole number 1 over 2. This will give us 8 divided by 2 is equal to 4 into 1 whole number 1 over 4 is the same thing as 5 all over 4. That is 4 times 1, 4 plus 1, 5 all over 4, plus 6.5 is the same thing as 13.5. 13 divided by 2, that is 2 times 6, 12 plus 1, 13 all over 2. So from here, this is 4 into the LCM of 4 and 2 is 4. 4 divided by 4 will have 1. 1 times 5 will have 5, plus 4 divided by 2 we have 2. 2 times 13 is 26. This is equal to 4 into 5 plus 26 will have as 31 all over 4. 4 will cancel 4 and we'll have our answer, the sum of the 8 terms in the sequence, to be equal to 31. That is the sum of the length of the 8 poles, 31 meters.